Welcome back, guys. It's AG. You're watching Math to the Max, and today we'll discuss dividing rational expressions. Okay, let's check out our vocabulary. So the first term we want to check out is an expression. It's a combination of numbers and letters with a math operation. Look at the example: 2x minus 4, x squared plus 6x minus 1, and 9x are examples of expressions. Rational is just a fraction, numerator over denominator. Reciprocal, a fraction flipped. Not the sign change, but flip. Numerator becomes the denominator, and the denominator becomes the numerator. Check out the example. So 1/3 becomes 3/1, which is 3. It is flipped. So what would be helpful to already know? Our prerequisites are simplifying rational expressions. Go ahead and check the video out on that if you haven't. Our factoring methods, GCF, factoring quadratics, are a combination of all of the factoring methods. It will be very helpful. So what's the process? Keep, change, flip. So we keep the first rational expression, change division to multiplication, and take the reciprocal or the flipping the second rational expression. And then you just factor your numerator and denominator if possible. Cancel any like factors out on top and bottom. And always simplify fractions if you can that's being multiplied if it's possible. So you're just following the same directions as we were multiplying rational expressions, except you're doing a keep, change, flip. All right, you know what time it is. It's time to go to work. Alright, so we're on division for number 1. When you first divide in, what we say you want to do is times the reciprocal. So rewrite the problem. Change your division to multiplication, and then you flip it, which we call the reciprocal. Alright, then you go ahead and factor. You ask yourself, can something factor from the numerator and denominator? Nope. Can something factor from this numerator? You should be saying, what kind of GCF? What's the GCF? 2 11 with x plus 3. 4x squared is a monomial. You never factor one term. Alright, so what counts? X plus 3's. Also, x squared. And then now you're just left with, at the top, 2 over 4, which simplifies to 1/2. Final answer. All right, let's check out number 2. So can we factor? Yes, so some people are like, hey, can I factor first and do the flip? Yes, it doesn't matter. You can factor it and then change it to multiplication and then flip it as a reciprocal. It doesn't matter the order. You just have to do either one of those two. All right, so I like to go ahead and rewrite it as x squared minus 25 over 3x plus 5 times the reciprocal, means flip it. The reciprocal means flip it. Alright, so can this factor? Yes, there is a difference of squares. What's the two numbers they gave us? Negative 25 is 5 and negative 5. Do 3x plus 5 have anything in common? Is it factorable? No sir, no ma'am. X plus 4, is that factorable? No way, Jose. Is x squared plus 3x minus 4 factorable? Yes, to the best. All right, what's two numbers y'all got? What's two numbers that multiply to be -4 and add to give us 3. Okay, you said it is +4 and -1. Now that you have it factored, I'm looking to see what can I cancel out on top and bottom. X plus 4s. That's it. That's it. So when you write your answer, what's left? X plus 5, X minus 5. And at the bottom, 3x plus 5, and then the x minus 1. Now, one thing I want to bring to your attention. If this was a multiple choice and you didn't see this answer, the only possible other answer could be if they actually multiplied it out. So by doing your distributive property, you can get the polynomial like x squared. It's going to be a quadratic trinomial. X squared minus 25. Well, in this case, it'll be a binomial because it's two terms. X squared minus 25. And then the bottom would have been 3x squared. Then it would have been a plus 2x minus 5. Right? But this is correct. They're showing you they could multiply it back out by doing the distributive property. All right, our last problem. 3 strikes and we're out of here. All right, so you need to factor this. Is this factorable? Yes, that's a quadratic slip and slide. I'm gonna do this to the side, just as a review. So 2x squared plus 7x plus 5. You try to slip over here, so x squared plus 7x plus 10. Can I find two numbers that multiply to give us 10, but add to give us 7? Yes. 5 and 2. Now, the number that you slip, that's the number that you got to slide back. 5 divided by 2 cannot simplify, so you move the 2 to the front. And then 2 divided by 2 simplifies to 1, so this is the factored form. So I'm going to go ahead and factor this. 2x plus 5 and x plus 1 over x plus 3. All right, so we factored. I'm doing this all in one step because some of you guys are able to skip steps, which is cool. Remember, you're going to change this to a multiplication, and then you're going to do the reciprocal, the flip it, the flip it, the flip it. X squared plus 4x plus 3 was two numbers that multiply to you 3, add to give you 4. X plus 3, x plus 1. Then the top part, remember, which is at the bottom because we did the reciprocal. What's the reciprocal? We got the reciprocal. What's the factor? Can we factor it? Which factoring method? GCF. What do these things have in common? They have in common 4x. And you left with x plus 3. All right, now we're trying to see what cancels. X plus 3 is canceled. You cannot cancel this x plus 3 because it doesn't have another pair. It has to cancel on top and bottom. Alright, so I don't see anything else that cancels. So our final answer will be what's left at the top. 2x plus 5. And we have an x plus 1 squared because it's two of them. At the bottom, x plus 3 times a 4x. I'm gonna put the 4x in the front. Alright, that's your final answer. We're done. Now you know how to divide rational expressions.
I hope this was helpful. Thanks for watching. Make sure you like, comment, and subscribe to the channel. Until next time, always striving for excellence
and reaching for success.